In this section, we're going to be talking about calculating slope. How do we use it? Slope, in the context of terrain surfaces, is used to describe the rate of change of a surface within a given area. Slopes can be used to also describe a surface. So, as far as landscape architects go, when we think about slope, we think about it in terms of rise over run, or rise over run times 100 equals some percent value, as we can see in this example here. If you are a contractor, and I can guarantee you as landscape architects, we will definitely work with a lot of these, they may refer to slope in terms of a ratio. So they'll say something like a 4-to-1 slope, or a 3-to-1 slope, or a 5-to-1 slope. And then sometimes you may hear slope referenced by an angle. So in this example, the angle theta would represent the slope that they're trying to describe. And slope can also be used to describe the percent rise, or basically the slope upwards or downwards, of both vector and raster type terrains. So what is exactly slope? What is it? So there are several equations that are used to describe slope mathematically, but they all yield the same results. So I'm giving you kind of more of a mathematical description of what slope is. So the first one, the most common one, is going to be rise over run, and it usually yields some sort of decimal value like 0.10, which represents a 10% slope, or 0.2, and we usually multiply it times 100 so we can get rid of the point part, so we can just say 10% or 20% slope. Sometimes we say it as the change in y over the change in x equals slope. And sometimes you may hear it referred to as difference divided by length equals grade. So those are the three most common equations that you might come across. So how do we use slope in more of a 3D environment? Because recall that our terrains are actually 3D. So let's just kind of take a look at this example here. We kind of have a flat plane followed by a little bend over here on the edge. So we're just going to kind of study this as our example to explore here. So we need to define a local or use a world coordinate system, or a combination of the two, which will be kind of helpful so that we can better describe the surface. So let's go ahead and throw in a 3D coordinate system, because recall that terrains are 3D. And we will assume that our plan view, so if we're looking down at this terrain, will be our XY plane for the sake of our discussion from this point on going forward. And that Z will represent elevation change, as we see here in this example. Calculating slope. So how do we exactly calculate slope? Well, there is a process. It's kind of a generic process that you can use to solve most math problems. So let's start with some assumptions here, and we're going to assume that we are interested in knowing the slope along the bend part of this terrain. So looking in our diagram over here from the previous example, we're only interested in this part that's bent, that's kind of sloped upwards. We're not really interested with this flat area, since we already know what the slope of that is. It's going to, it's flat. There is no slope. So we're interested in this bend part only. So the first step I need to do is draw a diagram. So what I'm going to do is take a section along the bend area only. So there's my section line. So here, this top diagram is more of a perspective view, and down here this is going to be more of a section cut view along that red line. So these two red lines are exactly the same. And the first thing I'm going to notice is that we are examining our section in the XY plane. So there's our XY plane. And looking at this, we can immediately see that we can form a right triangle. And after forming our right triangle, we can begin to assign variables and find knowns and unknowns. So we're going to denote the x part, or the run part, as the change in x, and we're going to denote kind of the rise part as the change in z. Next, we can set up our equation, and to do that we need to recognize some patterns and match to the equation of interest. So we are interested in using the slope equation, and we can kind of already see that we have most of this already set up, so we're going to write this as the change of z divided by the change of x equals slope. Next, now we just need to plug in our values. So we just plug in our numeric values into the equation. Since this is more of a generic equation, we don't really have any exact numeric values right now. We will in later examples. And when we do this, we want to use what I call clean mathematics. So what exactly is clean math? So your work is going to be checked by others. Just as your graphics must be clean, so should your calculations. So you want to define the equations you will use to run in your calculations. So you just want to have a sheet with a long string of numbers, and you just kind of hope the person who's checking your math can make sense of it all. You want to define exactly which equations you're using. That way people who are looking at your math, especially if you're working on a project that's rather expensive, you definitely want people to check your math. And you want to define your variables if it's not obvious, and then plug in values into the equation, and then go to solving, and then I'm going to show you some examples of exactly what I mean.